Hey YouTube, so this problem is problem number 39 from chapter 4 from the section on the mesh method with dependent sources. So let's describe this particular circuit. We have two voltage sources. This one is an independent voltage source of 660 volts, and this one is a current dependent voltage source with a value 20 I phi. And I phi is the current that's going through this 50 ohm resistor, and that's what's controlling this value. So the rest of the resistors are 5, 10, 15, and 25. Okay, so we are studying the section on, this problem is very solvable by node, but we're studying mesh, so we're going to use mesh to do this. Okay, so a mesh is a set of a closed path of circuit elements that don't enclose any other circuit elements. It's intuitive. So obviously this doesn't enclose any circuit element, and it connects the first node, the beginning node connects with the ending node in a closed loop. This is another mesh right here, and this is another mesh right here. So we have three meshes. So let's go ahead and label our mesh currents. So I'm going to call this one IA, this one IB, and then this one I'm going to call IC. So I have three equations, and however I have four unknowns. So in this case, the three mesh equations won't be enough. I'm going to have to get a fourth equation, and that fourth equation is going to come from the constraint equation. So it's going to come from I phi. So let's go ahead and write our four equations. So mesh at IA is going to be, we've got positive current, and the first terminal that it runs into is a negative terminal. So that means this is going to be negative 660, and then plus 5 IA. Just a reminder, the mesh method uses KVL, which says the sum of the voltage drops around a closed mesh is 0. So voltage is resistance times current, so that's why we got 5 for our resistance, and our current is IA. And then plus 15, and then the net current through that is going to be IA minus IC, and then plus 10, and then the net current of that is going to be IA minus IB. And all that has to equal 0. So our second equation is going to come from mesh at IB. So we have positive current IB. The first terminal that it goes into is the minus terminal. So that tells me this is minus 20 I phi. The next voltage drop is going to be across the 10 ohm resistor, and that has net current of IB minus IA. And then finally, the current through the 50 ohm resistor is going to be 50, and with a net current of IB minus IC, and all that has to equal 0. And our last mesh equation is mesh at IC. So that's going to start with 15 times IC minus IA plus 25 IC. And then the final voltage drop is across a 50 ohm resistor, so that's going to be 50 times IC minus IB. We have three equations, but unfortunately we have four unknowns: IA, IB, IC, and I phi. So that tells me the final equation is going to come from the constraint equation, which is I phi. So the voltage drop goes like that. And you see here the IB current is going to go through here first. So we know that this is going to be IB minus, and then the IC is going to come through the negative terminal first. So that's going to be IB minus IC. So we have I phi is equal to IB minus IC. So we're going to put everything on one equation. We're going to go IB minus IC minus I phi is equal to 0. And that will give us our fourth line for the matrix. So let's put our fourth equation here, IB minus IC minus I phi is equal to 0. And now we're going to create a matrix and have our calculator do the hard work. So we have IA, IB, and IC, and then IB, and constants on one side. From the first equation, we have 5 plus 15. Our IA coefficients are 5 plus 15 and 10. So that's 20 and 30. So that gives me 30 IA. IB, who we've got negative 10, one occurrence with negative 10 coefficient. And IC, we have negative 15 coefficient. We have no occurrence of I-phi, and this negative 60 will go on the other side as positive 660. And that's line number 1 of our matrix. Line number 2, we have negative 10 coefficient for IA. And for IB, we've got 10 plus 50, which is 60. And for IC, we have negative 50. We have negative 20 for I-phi. And no constants, so 0 there. Our third equation, we have negative 15 IA. And for IB, we have negative 50. And for IC, we have 15 plus 25 plus 50. So 15 plus 25 is 40, plus 50 is 90. So we got 90 there, and then no constants. No occurrences of I-phi and no constants. And then for our constraint equation, we have no occurrence of IA. We've got 1, coefficient 1 for IB, negative 1 for IC, and negative 1 for I-phi, and 0 for constants. So I'm going to take a second to make sure that is correct. Minus 10, minus 15, 0, 660, minus 10, 60, minus 50, minus 20, 0, 15, minus 15, 90, 20, 15, 25 is 40, 50, so 90, 0, and 0, 0, 1, minus 1 out. Okay, let's put it all in the calculator, in the simultaneous problem solver. 4 equations and 4 unknowns. 30 minus 10 minus 15, 0, 660. Minus 10, 60, minus 50, minus 20, 0. Minus 15, minus 50, 90, 0, 0. And 0, 1, negative 1, negative 1, 0. Solve. And to verify A, B, C, D. Okay, so let's go ahead and erase this and see what we got. So what you should have come up with is IA is 42 amps, IB is 27 amps, IC is 22 amps, and IP is 5 amps. Okay, that wasn't quite what we were looking for, but we needed all that information to get what we're looking for. So, we are actually looking for the power either developed or absorbed by the dependent voltage source. So power is voltage times current, right? So P of 20 I phi. That's just VI. Okay, so the value of the voltage, first of all, is the sign of that voltage is going to be the first terminal encountered by the current. So positive current through a voltage rise is going to be negative voltage. Yeah, so negative 20 I phi, that's the voltage, and the current going through that is IB. So let's put all our puzzle pieces together. So this is negative 20, I phi is 5. That's my voltage, remember, that's voltage. And so IB then is 27. So when we put that all together, we're going to go negative 20 times 5 times 27 is negative 2,700. So the power is negative 2,700 watts, or 2.7 kilowatts. The negative sign tells me this dependent voltage source generates power for in the closed system. So if it had been positive, then that means that that dependent voltage source would be receiving a charge from the 660. But in this case, it's negative, it's generating power. That's it, you guys. Make sure to like the Facebook link so that your friends find us.